Hello explorers and welcome to another video. Today I'm going to talk about Docker and Docker performance, and I have a video about packaging things in Docker with Maven. So if you are want an introduction video, then look at the eye up in the corner and you will get an introduction into Docker. So this is a little bit more advanced. We want to look at how we can package Java projects and make them really performant, small or cached and so on. And if we look at first the requirements, so my little project here will need Maven to build, and then some kind of Java, either Oracle 10, which I will use in one of my examples, or OpenJDK 11 for Alpine, which I will use in the other examples. And I will come to why that's the case. And what I'm going to build is my web server that I built using Swagger, and then I had some build process to create a server that you could actually use as a little web server as an example. So I wanted to package that into a Docker container, so I had a real project with some real restrictions and so on, so I know that it actually works after I have done this. And just to talk about some sizes, I have a standard build that you usually do when you build Docker with Java, and as you see here, it's quite large. It's 664 megabytes. And then I have a small one, 38.2 megabytes, and that's just the most important part of the JDK and the smallest image that's out there. It's actually an Alpine image that is only 5 megabytes. It's a really small one. And then I have a performance build that it's 52.2 megabytes, and that's when you have cached a lot of Java things, so the startup process should be faster, because when you run Java you have to JIT a lot of things, so it will compile in time and it will actually gradually get faster when you run it. And if you do some of the work beforehand and take a little bit of a hit when it comes to size, you can actually make it start up faster. And if you are in an environment where you want to take your Docker image and either start it really fast and do some quick calculations, or either start it up to take some work and then shut it down when you don't have that much work to do in an environment when you want, for instance, to scale up for demand or scale down. So the small commands we have here, these are just to build the different versions. And then this is to run them, so we actually expose the port 8080 out to the client. And then I have some commands down here, so you can look at what images you got and then prune the system and remove all that you have built. And do not run that in production. Very important, because it will actually remove everything. So this is just if you want to try it out and then clean your system afterwards, so you don't have any extra images lying around. So let's start by looking at the standard build of Docker. So this is the big one, but very easily to understand. You have a stable Debian build. I add the JDK and Maven, add some environment variables. I add the simple server, set the work dir, package it up, and then I have a command here to run it. So this is a very simple build, and it actually will create something that is 664 bytes and megabytes, and that's because this stable image, that's 300 megabytes, and this JDK, it's another 300 megabytes. So that's a really large image if you wanted to start quickly and send it over the network and so on. So it's not a small image, and we want to make it really small. So how can we improve on this? So if we look at a really small one, then I start by building on an Alpine. We talked about that, it was 5 megabytes. It's a really small one, but we have a limitation there that we need to use some build environment that is different from standard Linux, because it's built upon something that doesn't have glibc. It's built on another architecture called Muzzle, and you need to have something that it's built against muzzle. And OpenJDK 11 for Alpine is such an image, or such a build of the JDK. So I add that one, I add Maven, and as you see here, I also call this first one build. So this is a different image that I create. That's my build image. So it will create stuff, and then I will copy in the created stuff into my actual running image, and that's why I can make it really small. So I set up some environmental variables, I add my server, and then I run this Jlink script here. So I will create a new JDK with only the things that are required to run my program, and I will create a compressed one of those. That's making it really small, and if you remove this compress flag, it will become a little bit larger, but it doesn't have to decompress it when it starts, so that makes it a little bit larger, but it makes it a little bit faster. So that's a thing that you need to keep in mind when you're building these images. What's the most important? Where can I make my where can I take away either megabytes or speed? So you have to weigh these things to build things. And then we have the module path, so that's jmod, so you know where all the Java modules are. And then I need to tell it what modules my program will use. I will use Java base and the HTTP server, and then where it should put these things. And you might be wondering, how do I know what packages my application is using? And if you have a Maven project that you have built a jar file, you can actually use a command like this. You run in the Java 9 and above, you have a JDEPS, and you run it with the S flag, so it will summarize, or else you will get a lot of text. And then run that against your jar file. And if I do that, I actually get this little nice output here. It tells me that I need Java base and I need JDK HTTP server. So I know that those two libraries I need to add to my build, or those modules. And then I package it up with Maven, and then my build process is done. I actually have everything built. So I will start creating my real image, that image that I actually will push to production. So I will copy in the linked new JDK. So this is the new one that I created by Jlink, and then I copy over my built server over to the opt directory as well. I set some Java environment into the Java SH in the profile, and that's because that will be run every time the Alpine is started, so you know that you have these environment variables. And then I will expose 8080, and I have a command here to run my actual jar file. So this will create a really small image, but it's not the fastest because I haven't cached anything inside of Java, or I haven't cached anything in my build, so it has to do some jitting before it actually started. But that could be something that you don't mind, you just want to be small. But if we want to cache things, then we can improve this even more. So if we go to the performance one, you have a few small changes. These are the same up here, and after I have packaged my program down here, I run the JDK with the flag dump loaded class list. So this will dump a list of classes that is needed to run my program, and then I run it against mine, and I have a flag here that says debug, so it will actually not start a server, it will just set everything up as it would start it, so I know what things are running, and then it will create a class list for me. And then after that I run another command that first off dumps the shared JDK built classes. So this you can run just by itself if you like, and that will take everything that the JDK will use and it will save everything of that nature down to a file in your JDK directory. And if you start a JDK with the Xshare on, it will actually use that file, and the JDK will be ready and cached before you actually start your execution. But I also want to make my own program faster, so I unlock the diagnostic VM options and I add my shared class list file here, and then I create a new shared archived file, and this file will be classes built and jitted for my application, so my application will be faster as well. Then I copy everything over to my new image, so now I'm starting to build this production ready image, and you see here I copy over the JSA as well. And lastly, down here I say that I want to use the apps CDS, so that's the cached classes. I want to use that feature. I want to put share on, so it will use the cached files from the JDK, and I also want to tell it where my jumps around a lot here, where my shared archive file is, so it actually knows where to read my Java classes that it has jitted for me. And if I do everything like this, I will get some cached information that I copy over, and that is around 15 or 12 megabytes, somewhere around there. And if you have a full JDK, I think the numbers are 18 megabytes for the cached for just the JDK. So you take a little bit of a hit on the size of the image, but then again, you should get that back in a performance boost when you actually start the image. So you have to weigh these things against each other, what's important for you for your performance. I hope that you found this little video interesting. I hope that you learned something today. If you have any questions at all about this little process, please tell me down below in the comment section. If you like this video, give it a like, share it with your friends and colleagues, and if you haven't subscribed yet, please do that. And I really hope to see you in the next video.